So using the three functions up here in the directions, we're going to be finding different composite functions. So the first one here, f of g of x, can be rewritten as f of g of x. Then our inside function is the one we focus on first, and we're going to find g of x, and we plug that in for g of x. So g of x is 3x plus 1. Then we go to the f function and take out all of these x's and replace them with 3x plus 1. So this is going to be, take out the x, put in 3x plus 1 squared minus 5 times 3x plus 1. I'm going to need to write this factor down twice and then FOIL it out. You can't just raise the 3x to the 2 power and the 1 to the 2 power because of the plus sign here. So you are going to have to do some foiling. 3x plus 1 times 3x plus 1. And then don't forget we still have the minus 5 times 3x plus 1. Right, so I'm going to FOIL this out. So first, 3x times 3x is 9x squared. 3x times 1. 1 times 3x. And then 1 times 1. Now distribute the negative 5 through the next parenthesis. So negative 5 times 3x and negative 5 times 1. From here, we're going to combine like terms. So I'm looking at the squared term. That's the only one here. Plus 3x minus 15. So that's 6 minus 15, or negative 9x. And then we have a plus 1 and a minus 5, which gives me a negative 4. So we've gotten rid of parentheses. We've combined like terms. That's what we mean when we want it simplified. For part B, this is also a composite function. It's just written in a slightly different form. This is g of f of x. So they went right to this part right here. So we start with the g, find f of x, put that in. All right, now go find the g function, take out its x's, and replace it with what's in parentheses here, x squared minus 5x. So we have 3 times x squared minus 5x plus 1. And again, the simplifying part comes down to distribute, combine like terms if possible. So I have 3x squared, 3 times negative 5, negative 15x, and then the plus 1. Okay. For our next one, we're back to the circle there, the dot. So f of h of 4, f of h of 4. So we start inside here, we find h of 4. Well, the problem is I have h of x, I don't have h of 4. So what I'm going to do is, off to the side here, figure out what h of 4 is. So I go to the h function, back up here, take out the x. 4 minus 1 divided by 3. 3 over 3 is 1. So another name for h of 4 is 1. And then plug the number 1 into the f function. So we go up to the f function, take out all of its x's, put in the number 1, and then simplify it. So we're going to end up with order of operations, do the power, and then negative 5 times 1, add those together. Or just simply type it into your calculator just to make sure that you got the right answer there. This turns out to be negative 4. For letter D, g of 7. So I go find g of 7 first. Go up to the g function, plug in the number 7 off to the side here. Figure out what that number is. So 3 times 7 plus 1, 22. So this is g of 22. So now I go back to the g function, take out its x, put in the number 22. So we have 66 plus 1, or 67. Notice when we have a number here, we get a number out. And when we're plugging in with the x, we end up with x's, multiple x's sometimes out. So let's try this one. We've got h of g of x. All right, go find g of x. Nothing to plug in. We don't have a number here, so we're just going to take the full g of x and plug that in. 3x plus 1. All right, now go to the h function, take out its x, and put in what's in parentheses here. So I go to the h function, take out the x, and sub in 3x plus 1. Minus 1 divided by 3. Simplify the numerator, so 3x plus 1 minus 1 is just 3x. And then cancel the 3's out. All right. A similar idea here, we're going to do g of h of x. So again, you look for the inside function, h of x. I'm just going to take the entire h of x function, plug it in. So that was x minus 1 over 3. Now go to the g function, take out its x, and write down everything else, and then replace it with that x minus 1 over 3. So it's going to be 3 times x minus 1 over 3. And then it still had a plus 1 outside. These 3's can cancel, and I'm left with x minus 1 plus 1, which is also just x. It's kind of interesting on this specific question, h of g of x and g of h of x both turned out to be x. But that's not always the case. When we did f of g of x and g of f of x, they came up two totally different answers. So it's kind of a special case there with the h and the g function. For the word problem, we're going to see how composite functions apply to word problems. So for this one, there's an oil spill spreading in a circular shape. The radius is growing by 10 feet per hour. So in 1 hour, it's at 10 feet, 2 hours, 20 feet, 3 hours, 30 feet, for example. The area of the spill is a function of the radius, and then our area formula is pi r squared. If the oil spill has been spreading for 2 hours, what is the radius? So think about it. We said the radius is growing by 10 feet per hour, and if it's already 2 hours, our radius is going to be 10 times 2, where it's already going to be up to, 20 feet? What is the area after 2 hours? Well, the area after 2 hours, our radius is 20 feet, so we're going to plug in 20 feet. It's going to be pi times 20 squared, or 400 pi, and then area is in feet squared. I'm just going to leave it with the pi symbol to keep it exact, rather than round it to 3.14 and then multiply. So if it's been spreading for 4 hours, what's the radius? Well, again, every hour it grows by 10 feet. So after 4 hours, 4 times 10, it should be to 40 feet. And then the area after 4 hours, well, the radius is 40 feet. So I'm going to plug in the number 40 in here, pi 40 squared. And that's going to come out to 1600 pi feet squared. See how we're kind of doing it in 2 steps. We figure out the radius, and then once we have the radius, we plug it into the area formula and then go. So we're going to kind of put this together in terms of a formula. Construct a function r of t that represents the radius of the function of time t in hours since the oil spill. So the radius at any time now, so not just 2 hours or 4 hours, but at any time t is going to be 10 times t. So if t is 2 hours, then we're at 20 feet. If t is 4 hours, then we're at 40 feet, for example. So we have a function r with respect to t. How could you compose the function a and r to give you area in terms of time? Well, we know that our area formula was pi r squared. So instead of r, we're going to plug in 10t. And now it's going to be in terms of t. Square the 10, square the t, and I end up with 100 pi t squared. So now if I want to know the area at, for example, time equals 2 hours, I would plug in the t as 2, and I'd get 100 pi times 2 squared, which is 400 pi. So I can go directly to this formula right here, 100 pi t squared, and plug in and get the area in feet squared, instead of doing it in 2 steps, figuring out the radius, plugging the radius in, and then getting the area. I can go right to, I know what the time is, I can figure out the area directly.